Okay, so today we're going to be solving systems of equation in 3 variables. This is the instructions in words. Choose variable to eliminate, then choose any 2 or 3 equations to eliminate chosen variable. Select a different set of 2 equations to eliminate the variable in step 1. I'm going to solve and then substitute in. What I tried to do is make a little bit of an organizer here to help us out. So let's look at this first problem here. First thing I got to do is get down to a system of 2 equations. I'm going to need to eliminate one of these variables. So let's look here. The easiest one I believe to eliminate is going to be y because we have opposites. And the equation I'm going to use in both sets of equations is this guy because this is the only one that's positive. All right, so we're going to opt to eliminate y. So let's write that equation in both spots. I'm going to rewrite it over here. So 2x plus 5y minus 3z is equal to minus 10. All right, then we need to write each of the other 2 equations to make pairs. So I'm going to take this first equation here and write it down here. So it's going to be minus x minus 5y plus z is equal to 17. And the second equation, we're going to pair up with the one that we're using in both. So minus 5x minus 5y plus 5z is equal to 5. All right, so now what we want to do is actually eliminate a variable. So we want to eliminate the y's. Luckily, we have opposites here. And what we're going to get ourselves when we combine everything is x minus 2c is equal to 7. And again, they're going to eliminate over here because they're opposites. We're going to get minus 3x plus 2z is equal to negative 5. Okay, so once you've got your 2 equations, which is 2 variables, we're going to write them as a paired system. So we're going to rewrite this as x minus 2z equals 7, just like we've been practicing, minus 3x plus 2z is equal to minus 5. And when I looked at this, I got very excited because the first thing I noticed is that we have opposites on the z's. So now we need to solve the system of 2 variables. So these guys are going to cross out. We have minus 2x is equal to 2. Divide each side by minus 2. And I find x to be equal to negative 1. Don't love the yellow. Okay, so our next step is to solve for the second variable in that 2 system. So I'm going to use the first equation of x minus 2z is equal to 7. I'm going to replace negative 1 in for x here. I'm going to add 1 to both sides to solve for z. I want to isolate that z. Here we get minus 2z is equal to 8. Let's continue that problem. Ran out of a little bit of space. Divide each side by negative 2. And I find z to equal negative 4. I'm going to go and box that. Our next step is to figure out what that third variable is. And in order to do that, we're going to have to go back to the original system and pick any one of these 3 equations to substitute in the 2 that we know and solve for the third. I'm going to choose the first equation, but you can pick either. So the first equation was minus x minus 5y plus z was equal to 17. I know my x is negative 1, so it's going to be minus negative 1 minus 5y minus 4, because z is equal to negative 4. We already figured that out. 2 negatives become a single positive. Combining like terms, 1 and minus 4 is going to get us minus 3. I'm going to add 3 to both sides. Going to continue up over here. Minus 5y is equal to 20. divide by minus 5, divide by minus 5. We get y is equal to negative 4. Now that I've found all three, we want to write them as an ordered triple. It means you need to go in alphabetical order. So we're going to go x, y, z. So our answer should be negative 1, minus 4 for y, minus 4 for z. All right, I'm just going to do 2 problems on these videos for today. So let's kind of look at the same thing. This one's also making me focus in on the y variables, just because I have the one positive. So this is the one I'm going to use in both sets. This time again, we're looking to cancel out the y. I'm going to rewrite the equation that I'm using in both spots. Good. Okay, I'm going to write the second equation over here. Plus c equals 0. And the third equation I'm going to pair up with this guy. Okay, so let's do our eliminating. And luckily, again, we have opposites here, so these guys are going to cancel out. On this side, we get 6x. I don't think I want to use yellow for this. Let's go back to the purple. That was a 2x. So combining these up, we're going to get 6x plus 2z is equal to 24. Here they cancel out as well. We get 9x minus 4z is equal to 24 and 12 is 36. All right, and then what we're going to do is write them up as a system of equations. So we're going to get 6x plus 2z is equal to 24. Over here we get 9x minus 4z is equal to 36. Now the problem here is I don't have opposites. What I can do is change this 2z to be a 4z. So I need something to cancel out this minus 4z. I'm concentrating on the z's because they're multiples of each other. So what do I need to multiply 2z by to get 4z? Well, that's going to be 2. All right, so let's distribute this guy through. 2 times 6x is going to get us 12x plus the 4c, which we said before, and that's going to equal 48. 24 times 2 is 48. We're not multiplying the bottom equation, we're just rewriting it. And now we're going to eliminate the z variable. Let me just move this down just a little tiny bit. Okay. Over here, I get 21x. And when you add 48 and 36, you do get 84. Dividing each side by 21, we get x is equal to 4. Okay. Now we need to solve for the second variable in our 2 system. I'm going to use that first equation of 6x plus 2z is equal to 24. I'm going to substitute 4 in where we see this x. We are going to multiply these guys out, so we get 24 plus 2z is equal to 24. I'm just going to rewrite that up here because I ran out of a little bit of space. Subtracting 24 from both sides, we get 2z's equal to 0. Dividing each side by 2, we figure out that z is equal to 0. Okay, now we've got 2 of the 3. Like I said earlier, you're going to go back to your original equations. I'm going to pick the second one this time. That looks like a little bit easier numbers to work with in order to substitute in to find that third variable. So our equation is 2x minus 4y plus z is equal to 0. We know x is 4. We're looking for y. We know that z is 0, so plus 0. That guy's just going to go away. It's going to be 8 minus 4y is equal to 0. Subtracting 8 from both sides. We continue right up here. These guys will cancel. Don't lose that minus. Minus 4y is equal to negative 8. Divide through by negative 4. And we get y is equal to a positive 2. And then finally writing our answer in XYZ form with the parentheses. It's going to be 4, 2, 0. All right, and with that, we're concluding the video lesson. The other two problems will be done in class, and the answer key will be found on the website in Schoology after today's lesson. Thanks, guys.